All right, guys, in this video, we are going to wrap up the 5.3 section. In the last video, we talked about sum and difference identities. And in this video, we're going to talk about double angle identities. So we did have some properties here. I'm going to put them back up on the screen really quick so that you can see what these looked like. Okay, now these do come from the sum and difference identities, and we will kind of see that in a few minutes, where we're going to actually prove one to get going. Actually, it's going to be this one for sine. That's what we're going to prove here in just a moment. But all of these are the double angle identities, and they do come from the sum and difference ones. If you imagine, if you see sine of 2u, remember that's this 2u would be the same thing as u plus u. So technically, you can use a sum identity to do that. And so that's kind of where these things come from, is those identities. And we'll kind of go from there. So here we go. If you did miss the last video, make sure that you go back and view it. Or if you missed the last lesson, please make sure you watch that video so that you are able to understand what's going on a little bit more here. But this is example 5, and it's another proof. So we're going to go through and show the steps for it. I'm also going to kind of justify as we go through the steps as to like what properties we're using or identities or whatever. That way it's really more of a proof than just an algebra problem. Okay, so now when you have a proof and they say to prove that this is equal to this, what I need to do is I need to start with one of the sides of this equation. You don't start with both from the get-go. We typically will start with just one of the sides. I'm going to start there with the left side and say, okay, if I've been given sine of 2u, what can I do with that? Okay, well, I know, like I said a moment ago, that this is technically the same thing as u plus u. Okay, so that's just kind of expanding. And so if I wanted to give a little property or whatever I did to justify why I wrote what I wrote, we just expanded. It's like a notation thing. So we expanded the 2u. Okay. But from there, we'll actually use a property because this is u plus u. So I'm going to bring this back. This is sine of a sum. And so we're going to follow the property for sine of a sum. You see here, we're going to use that top symbol, that plus. So we'll have the top symbol in there as well. So that's the pattern that I'm following, okay? Our pattern says that we need to take sine of the first value times cosine of the second value. They just happen to be the same thing here, okay? And then I'm supposed to have a plus. We should have cosine of the first value and then sine of the second value. But I want you to look here, okay? And this was the sum difference identities. You can say sum difference identities. If you want to abbreviate, I'm fine with that. Okay, now I'm going to swap the order here to make it look like, because I want sine and then cosine. This one is already in the right order. Sine u, cosine u. But this guy, we need to swap the order. And that's one of those properties from like Algebra 1. I know it's been a while. But this is that commutative property. I'm just going to say prop. Okay. Next thing, because this is sine u, cosine u, we can add those and make it 2 sine u, cosine u. All right. And right there, that's what we were trying to prove. The last thing I did here was I simplified. But I have proven what I wanted to prove. Yeah. All right. So that's all there is to that. Again, when you have a little proof, just make sure that you give a little justification for each line that you do. And then it's proven. So, okay, cool. We got one more. This is example 6. They said we're going to solve this on this interval. So we're going to use our identities to help us with solving again. And then this is my last one, y'all. Again, we do need to pay attention to the interval, the 0 to 2 pi thing. So it's always important to watch out for instructions on that type of thing. Okay. But I'm starting out with that equation, sine of 2x equals cosine of x. And I've got to decide what is going to be in my best interest. I can't write. I'm going to try that again. 2 sine of 2. Oh my gosh, y'all, I'm losing my mind. I haven't had any coffee yet today, and it is early morning. I'm going to try this again. I was trying to find my whiteout. I don't know where I put it. Okay, I'll try this again. Sine 2x. And we're saying equals cosine x. Now, this one's not a proof, so you do start with both sides here. Okay, so I'm going to figure out what property can I use. Well, there's not a whole lot I can do with just plain old cosine. However, sine of 2x, we do have that double angle identity. I'm just going to kind of follow along from up here because that's right there on my paper. And the way that we rewrite this is 2 sine of x cosine x. And we just proved why that was a thing, right? Once you turn it into this, it becomes like the last section. So honestly, from this point on, it's like what we did in 5.1. I'm going to subtract the cosine to be on the other side. That's equal to 0. We're going to factor out a cosine. So this is 2 sine x minus 1. And there's not a whole lot more I can do properties-wise here. But I do have something times something that equals 0. One of those somethings has to be 0. So we're going to use that zero product property there and say cosine x equals 0 or 2 sine x minus 1 equals 0 and solve each of those. Now, on the interval 0 to 2 pi, we got to look at where is cosine 0. That's where your x values are 0. That would be at pi over 2 and 3 pi over 2. This guy's going to take a little bit more to solve with, so I'm going to add the 1 over. This is 2 sine x equals 1. Then sine of x equals 1/2. All right, so I'm looking at my unit circle. Where is sine 1/2? Where is my y value 1/2? And that is at pi over 6 and 5 pi over 6. Because my interval was just 0 to 2 pi, I do not have infinitely many solutions. I do have to list all of the solutions that are within that range, but that's right here. So I'm going to list them in order just to make this prettier and maybe write it as a little set here. So my smallest one was pi over 6, and then we had pi over 2. Then we had 5 pi over 6, and then 3 pi over 2. And we got it. All right, guys, that is it for this lesson. Make sure that you give the assignment a shot, and I will see y'all in the next one. Bye.